All right, we're about to tackle one of the biggest, most mind-bending questions you can possibly ask. It's something that feels like it's pulled straight out of a sci-fi movie, but it's being seriously debated by some of the most brilliant minds on the planet. So yeah, let's dive right in. So let's just put the question right out there. Is our reality a simulation? This isn't just a fun little what if anymore. The idea that our entire existence, everything you see, you feel, you experience, is actually a super advanced computer simulation, well, people are taking it incredibly seriously. And I mean really seriously. This isn't some fringe theory cooked up on the internet. We're talking about leading philosophers at places like Oxford, physicists who are exploring the absolute deepest levels of quantum mechanics. The simulation hypothesis has officially moved out of the movie theater and into the lab and the lecture hall. So how in the world do you even begin to investigate something like this? Well, it's kind of like a detective story. You have to follow the clues. And it turns out our universe might be full of them, hiding right there in plain sight. Let's start looking at the evidence. Okay, so our first clue comes from the very language of reality itself. Have you ever just stopped and noticed how perfectly the universe seems to follow a very specific set of rules? Well, what if those aren't just rules? What if they're actually code? Just think about it for a second. The laws of motion, they're equations. Gravity, described perfectly by mathematics. The behavior of tiny little particles, that follows statistical rules. It really seems like our entire universe is built on this bedrock foundation of math. It's almost as if reality is running on some kind of incredibly sophisticated operating system. This whole idea is actually the core of a field called digital physics. It basically suggests that at the very bottom of everything, reality isn't made of tiny bits of matter, but of pure information. Think of it like the ones and zeros in a computer. And if everything is just information, well, that means our universe could, in theory, be computed. All right, let's move on to our next clue. And for this one, you might want to buckle up, because we're diving deep into the bizarre, totally counterintuitive world of quantum mechanics. This is where things get really weird, and where that video game analogy starts to feel almost a little too real. So, if you've ever played a video game, you know the computer doesn't draw the entire world all at once, right? That would take an insane amount of processing power. It only renders the parts that you, the player, are actually looking at. So, what if our universe does the exact same thing, just to save on computational resources? And this is where it gets crazy, because that video game analogy maps to our reality in a startling way. In quantum physics, there's something called the observer effect, which shows that tiny particles, like electrons, they don't seem to have definite properties until we actually measure them. It's like reality only bothers to render the details when we look. And just like a computer screen has pixels, our universe seems to have a minimum resolution, a fundamental pixel size. And scientists think they've actually found that pixel size. It's called the Planck length, and it is the smallest possible unit of distance in the entire universe. I want you to think about that. Below this incredibly tiny length, the very idea of space just stops existing. It suggests our reality isn't this smooth, continuous picture. It's made of discrete individual units. In a very real sense, our universe is pixelated. So our third and final clue doesn't come from physics at all. It comes from pure, cold, hard logic. It's a powerful thought experiment from the philosopher Nick Bostrom, and it kind of forces us into a very strange corner. First, just look at our own technology. A few decades ago, we had Pong. It was two rectangles and a dot. Today, we have photorealistic virtual reality that can be genuinely hard to tell apart from the real world. If you just follow that line of progress, it seems almost inevitable that our descendants could create what are called ancestor simulations, simulations of their past that would be completely indistinguishable from reality to the people living inside them. Okay, so this leads us to what's called Bostrom's trilemma. He argues that one of these three statements absolutely has to be true. Option 1, humanity goes extinct before we can make these amazing simulations. Option 2, we survive, but for some reason, we just lose all interest in making them. Or there's option 3. If you think the first two are pretty unlikely, then it means that countless simulations will be created. And if that happens, there will be way more simulated people than real non-simulated ones. And if that's the case, then just by pure statistics, we are almost certainly living inside one of them. So, let's recap. We've got a mathematical universe, a rendered reality that seems to be pixelated, and a powerful logical argument that's hard to poke holes in. It's a lot to take in. But, it all leads to maybe the biggest question of all. If this is a simulation, does any of it even matter? For a lot of philosophers, the answer is a resounding yes. It still matters. Because think about it. If you can't tell the difference, then what is the difference? The feelings you have, the relationships, the discoveries, all of that is completely real to you. Your consciousness is the constant here, no matter what the substrate of your reality is made of. Let's just make this personal for a second. Is the joy you feel any less joyful? Is the love you have for your family and friends any less profound just because of this idea? If the experiences are authentic to you, the one experiencing them, then maybe the nature of the stage they play out on is totally irrelevant. So, what's the big takeaway here? Well, we've seen that this whole simulation hypothesis isn't just a fun idea. It's based on real observation and logic. Our reality seems to have these strange properties that are eerily similar to a computed system. And ultimately, it forces us to ask this incredibly profound and personal question. What does real even mean? And does the answer change anything about how we should live our lives?
So we're left with one last thought to chew on. If we are in fact living in a simulation, you'd expect there to be bugs, right? Glitches. Things like déjà vu or bizarre coincidences that just don't make any sense. So the question is, what glitches in the matrix have you noticed in your own life? It's definitely something to think about.